Hello and welcome to Introduction to Functions. Today we will be focusing on the key attributes of a parent function. This lesson will cover conceptual understanding of functions and their attributes as well as their characteristics. We'll also try to connect functions to everyday life or real life situations. We also will talk about procedures of how to solve equations, formulas, and things of that sort that deals with the key attributes and characteristics of a parent function. We also will work on being able to declare or identify what a function is based off of its characteristics and traits or attributes. Meaning that we might be able to look at a table, a graph, or just even by the rules and understand what this particular graph function is. We'll also be covering subjects that you have had in the past as a refresher. Basically the things that you should already know. And we'll work on building skills on certain qualities or skills or traits that you'll need to know to be successful as far as understanding attributes to a function. We'll build on skills, and those are things that you really do need to know. And we'll practice the things that you have to do to be able to identify, recognize, represent, determine attributes of a function. So let's get started. Okay, what should we know? A, we should know what a function is. Our prior knowledge should tell us that a function is assigned a single unique output for each of their inputs. Let's look at two tables to better understand. Functions using notation. Okay, let's dive straight into it. The set builder notation. When I first look at it, I swear, I think I'm reading a foreign language, and after doing more research, it is a foreign language. So what does this mean? Each symbol has a meaning that can be interpreted. Take for instance the E. The E equals element, or it means element. The R, it stands for real numbers, and the line, it stands for such that. So let's pay attention to the set builder notation that is above elements. And if we look directly to the right of it, we can see how to say notation. The way that we would interpret this set builder notation, we would state it as all x that are elements of the set of real numbers such that the value of x is greater than 0. Also in this lesson, I want you to pay attention to the interval notation. Please do not forget from Algebra 1 that negative infinity goes negative and positive infinity goes positive. It runs forever. That's what infinity is. So when you see it, do not get overwhelmed. Let's keep everything pretty simple and just remember inverse of a function using notation. Alright, first of all, we got to think about it. We're not going to make it more difficult than what it is. The inverse of a function. A function that undoes the original function. So what does that mean? If we look right here at our diagram, we can see that all of our numbers on our right hand side traded places or interchanged with the numbers on the left hand side. So when we do inverse of a function on a table. Okay, first of all, I want to deal with a misconception. Before we start anything, I want to ask you, the inverse of a function, is it the opposite sign, or is it the reciprocal of the original function? Keep that question in mind as we begin to look at this graph or this table. Okay,